Hello everyone, my name is Hasham and today we'll be looking into multi-agent systems. Before we begin, let's do a quick recap of what an agent is. So an agent is basically comprised of a prompt template which tells it what to do. It uses an LLM to do its reasoning, its thinking, what it's supposed to execute and all of that. And it also keeps a memory of everything it's talked to the user about to kind of know the context about what it's supposed to do next, what it's already talked about, things like that. And to converse and interact with the external environment, it uses tools. So now let's move on to the multi-agent systems. This is basically different from having a single agent because instead of having just one agent, multiple agents are interacting with each other to accomplish a single task or goal. Now there can be multiple tasks or goals as well, but for the sake of this video, let's just consider them to be trying to complete one task or goal. So what are multi-agent systems? Multi-agent systems are often better for complex tasks because they work together and efficiently. So instead of a single agent, so let's say a single agent trying to accomplish a task, all of these different agents, they will work together to accomplish that shared task or goal. We'll cover a few examples of these, and this allows for specialization of these individual agents. So let's take a simple example of, let's say, a blog writing agent. Now for this task of blog writing, one agent could do all of the different tasks associated with it, such as doing the research, doing the writing, doing the reviewing. But in that scenario, there's very less modularity. There's also a bit less specificity and control. So in order to make this entire system better, what we can do is we can branch out all of these different individual tasks or like subtasks that have to be accomplished to write the single blog. So let's say it could be the research, it could be the writing, it could be the proofreading. So proofreading, also maybe even the editing, and maybe we could even have like a publishing agent to publish this on our social media, things like that. So what we do is, instead of having one agent do all of these different tasks, we divide these into different components, different agents, and they each accomplish their individual task, and combining all of that, the overall system goal or like task is achieved. In this manner, if they work, they each have their own specialization. So let's say the researching agent would be specialized to do research, the writing agent would be specialized to do writing, and so on. And since they are very modular, again they're very specialized, we can control their specific outputs. So we can tell the research agent, hey, you're only supposed to do research in this domain, or you're not supposed to go out of bounds in this entire area. And for the writing agent, we could give it instructions like, hey, you're supposed to write it in a simple manner, it's supposed to be user friendly to understand, you're supposed to use non-technical language, and so on. And another big factor, a big plus point, is we can use different LLMs for each of these agents. So let's say if you're working with code, you feel like Cloud works very well for that. Your coding agent could be built on Cloud. Let's say if it's like a research agent and you feel like ChatGPT is very good for researching, you can make the research agent using ChatGPT. And this also helps us to improve the accuracy and reduce the hallucinations by these different agents and LLMs. Because again, these LLMs do have like a limited context window. So if you're giving an LLM like 50 different instructions on how it's supposed to write the blog, it could get confused. But if you break down those 50 different, let's say instructions or subtasks into like, let's say sets of 5, then each of these could be accomplished in a much better manner. Now, this can also allow for parallel processing. So while one agent is doing, let's say, your research, the other could go out and find and maybe even generate blog images for you. Once the writing is done, the proofreading, the editing, maybe all of this can be parallelized. And that is the power awarded to you by using multi-agent systems. And these can be of different natures as well, so they can either work collaboratively or even competitively, and we'll look into all of these in much more detail. Now there's different types, structures and strategies that are used to build these multi-agent systems, namely cooperation, competition. For competition, I'm sure you've also heard the term adversarial, so that's also a term that's used. There's also competition. These can be centralized, distributed, or even hierarchical. And these can be based on different strategies, such as, let's say, a rule-based system, or like a role-based system, or even a model-based system. Most likely you'll be looking at role-based system, and we'll talk more about that in a lot more detail. So first, let's look at the different collaboration types. We have cooperation, competition or adversarial, and cooperation. So let's first look at cooperation. In this scenario, different agents, so let's say we have these different agents, they are working together to accomplish the single task or goal. Now these agents, their objectives are aligned, so they have to work together towards the shared goal. And the advantages for this is that each of these agents can have like a specific strength or a specialization, and they can use that to work towards the overarching goal or task. And these are simple to design and execute, because again, we could have the research agent doing the research, the writing agent could do the writing, and so on. However, there are also disadvantages with the system. If the goals are misaligned, it can cause inefficiencies. So let's say if you have a system where your writer is supposed to write it in a technical manner, but your reviewer is supposed to review it in a non-technical manner. So like this. Now here, even though they're working towards the same shared goal of writing the blog or whatever it is, because their individual goals or prompts are towards different alignments, they can clash with each other, and this can cause inefficiencies. This can also cause recursion to occur, and so on. Now, in this scenario, one agent's failure can also be amplified. So let's say you task your multi-agent system on blog writing to write a blog about apples, but instead you maybe told it to just write the blog on Apple. So it misunderstood and it wrote on the company Apple, which makes iPhones, Macs, and so on. Now, since the research agent has researched on Apple, the writing agent has wrote on Apple, the reviewer agent and editor agent, all of these are working towards the goal of Apple. But that's not what your original goal was, right? So in this manner, the individual failures can also be accumulated and amplified. Like I mentioned, good examples are, like, let's say research writing, so doing research, writing based on that. This can also be used for things like decision making, question answering, and so on. Next, there's the competition type. So in this scenario, these different agents are trying to work against each other. Now this has a fair bit of advantage because it pushes each of these agents to perform better. So let's say in our blog writing scenario, we had the reviewer agent, or like let's say, and the editor agent. We can have them work against each other. So whatever the editor edits, the reviewer is supposed to scrutinize that, it's supposed to critique it, try to make it better. And then the editor can take all of that different feedback, and it can convert it into a better editing system. It can make better technical edits, for example. And this promotes adaptive strategies. So let's say if you see one of your agents is failing on one particular edge case or a task, you can maybe have a different agent counteract that to make it to help it work better. Now this needs mechanisms to resolve conflicts. If you don't have these two different agents will keep clashing with each other, and it will keep going in a recursion. So let's say the reviewer agent, it reviews it, it says, I don't like this. The editor edits it, the reviewer agent again says, I don't like this. The editor again edits this. Now it can keep going in a loop and so on, unless you have some fail safes. So you need to have some fail safes to kind of prevent this. People sometimes use human in the loop, and there's also other strategies to mitigate all of this. Now, this competition should be beneficial. So if you have agents working against each other for no reason at all, it's not really a beneficial system, right? So you kind of need to think on how these agents are supposed to work together with each other. Good examples are for, let's say, debating, question answering, even the blog writing example I wrote. So the reviewer agent is always supposed to give you critique. The editor agent is always supposed to write good edits to kind of mitigate those critiques. So next we have the co-opetition. Now in this scenario, we combine the competition and the collaboration. Now we combine these, and then based on the shared tasks, some agents are working together, some agents are working against those agents. So let's say in a blog writing example, the research agent, so the research agent and the writing agent, they will be working together. Then the editor agent, let's say this is the editor agent, and let's say this is the reviewer agent. So the reviewer, these will be working against each other. So these will be working competitively. And in this kind of like mixed manner, you could have some agents collaborating with each other, you could have some agents competing with each other. Now we need to kind of balance the trade-offs for like when they're supposed to agree with each other. So these two, they have to come to terms with each other at some point. There's not many case studies on this. Again, these are used very effectively, but a lot more can be done on the mitigation strategies. Good examples are negotiation, your writing, reviewing, and so on. This is just a visual example to show you guys, but let's say in this specific system, the academic writing support agent, all of these agents are working with each other. In the competition one, let's say we could have like a court simulation. So there's the prosecutor and the defendant, and they always have opposing arguments. You could build these agents and maybe try to get like a simulation of a court case trial or something like that. We can also have like a competition policy making system. So let's say there's a policymaker and there's an agent that's for that certain policy, and there's an agent that's against that certain policy. So this is kind of like one agent is working collaboratively while one agent is working in a competition. So this is an example of like a competition system. There's a few other examples even in like the cooperative one. So when they're collaborating, they could be ordered. So let's say we always know, so we know that this agent is supposed to always call this agent and then this agent and then this agent to kind of work towards the task or goal. We could also have an unordered system in which each of these agents figure out who to talk next to. So let's say the reviewer agent, once it's done reviewing, it can decide whether it still needs to send it to the editor or maybe it just needs to publish that. So we have the agents figure it out for themselves. In the adversarial one, there's another example. Even in the mixed examples, some agents could be working in parallel. Let's say these could be working collaboratively, these could be working competitively, and these again are working towards the same shared goal. We have hierarchical systems as well, and let's talk about that in a bit more detail now. So next is the communication structures. We have the centralized, decentralized, and hierarchical structures. First, let's look at the centralized. So in this scenario, the collaborative decision is concentrated on a central agent. So this central agent is, let's say, talking to the user, and it uses all of these different agents to have its work done for it. This is a good system to use in case of like a simple design that you need to implement and efficient resource allocation. The disadvantage for this is if the central node fails, the entire system might collapse. So let's say if your central agent isn't working properly, it's not talking to the user, it's not getting their correct intent. In that scenario, all of this structure will fail, because just this main agent that's conversing with your user, it can really figure things out, right? And this system is less resilient to disruptions. So let's say again, it can't understand the user's intent, or it always sends it to the wrong agent to accomplish the task. In this scenario, it's like very error prone, so you kind of need to work around this. Good examples for this are again question answering and decision making. Next, we have the decentralized system. So in this scenario, in this collaboration method, the workload is distributed among multiple agents. So when you start talking, you can maybe start talking to this agent or this agent, and this query can be routed to these agents based on another architecture which we'll discuss a bit later. And based on that, they figure it out for themselves that, hey, this is not my task, this is supposed to go to XYZ agent. It sends the user's query to that agent. That agent then figures out, oh, I can do this. But to be able to accomplish that, I need to work with, let's say, this agent. So they kind of figure out the entire system for themselves. And because of this, they can continue to function even if some agents fail. It has high scalability because there's always agents talking with each other. And these agents can also operate autonomously because they know which agents they're connected to and what task is supposed to be accomplished by those agents. And because of that, they can also adapt to system changes. These agents are trying to figure out who to send this message to next, also what they're supposed to do, what the next agent is supposed to do. So it does have a bit of an overhead as well because of that. And good examples for this are again question answering in certain scenarios, decision making. Reasoning is like a very good scenario for this. If one agent is unable to reason for your specific query, it can send it to a different agent that's more specialized, more trained to accomplish that task. And there's a few other examples as well. Next, we have the hierarchical system. So this is a really good one. Agents are arranged in a layered system with distinct roles and levels of authority. So if you look at this example, whenever you send the query, these first three agents get maybe access to that. Maybe even instead of that, you could have like the query over here, and you could have like a routing agent to send it to, let's say, agent 1 or agent 2 or let's say agent 3. Now in this scenario, this routing agent has the highest authority. It decides whether it goes to agent 1, agent 2 or agent 3. In the previous example for like the centralized and decentralized one, all of these were equal level. So they were on the same level. They could decide amongst themselves who the query would go to next or what to do with it. But in this scenario, in the hierarchical or layered system, the routing agent or like the agent with the higher authority has the deciding power. Now, the advantages for this are that there could be low bottleneck as communication tasks are distributed across levels. So if the first three agents can't figure it out, only then does it go to the next level and the next level and so on. This allows for efficient resource allocation as well, and tasks are often offloaded among these different levels. The disadvantages for this is like if the edge agents, which are these agents, if they don't work, then it becomes critical, and a failure in the edge agents leads to a system failure. So if these individual agents do something wrong or like the task isn't accomplished by them, then the parent agents, they just take in that wrong output from like the sub agents and just use that to answer a query or do something or accomplish a task. In this scenario, if again these edge agents are giving you the wrong output, then that wrong output goes to the parent, and that's again also wrong. So when it answers your query, the answer is also wrong. This also has a slightly higher complexity and latency because the parent agent has to decide which subagents to call. These subagents can also call their subagents and so on. So it does have like a bit of a communication overhead because it has to go from the top to the bottom and then come back from the bottom to the top. So we have those. Examples are again question answering. An example is reasoning. A big example for this is routing. So people have routing agents to, let's say, route a user's query to different sub-agents. Let's say if you're in a marketing or like sales environment. So in that environment, there could be 5 different sales agents trained on different areas of like a product or something. And the routing agent has to decide which actual sub-agent to send that query to. And then that sub-agent kind of helps the user understand their queries, understand their problems, and navigate all of that. So looking at a few examples, we can see here in the equal level structure, this could either be collaborative or competitive. So these 3 agents are on an equal level. In this scenario, they're distributed and they can either work collaboratively or competitively with each other. In this scenario, it's a hierarchical structure. So the parent agent or the leader sends the query or like the subtask to one of these agents and makes them accomplish like a certain portion of that bigger overarching task. And using all of that, it can give you the answer. We could also have nested structures. So the parent agent, let's say, sends it to this agent. And this agent can also, let's say, have different agents that it's working collaboratively. And once all of these 3 agents have figured out what to do for that specific task, they send it to the parent agent, and then the parent agent accomplishes that task. This is another example of like a hierarchical agent. So the user sends a question. The supervisor agent decides which agent to send it to. So let's say it sends it to agent 1. The agent 1 uses its prompt, which has its instructions, it uses its tools and accomplishes that task. So in this scenario, let's consider the user asked a question, how do I sort my data? Now let's say this is like a SQL agent. It sends it to this specific agent, which is supposed to help with like the sorting related queries, maybe something like that. It uses its certain tools, its prompt, and says, hey, this is the SQL query or something like that. You can use that to sort your data. And then this is sent to the supervisor agent, which it uses to generate the response for the user. Next, there's even different collaboration strategies. So you could have like a rule-based system. In this scenario, you have very specific set rules for your different agents that you only have these certain XYZ scenarios. You're supposed to be hard-coded to only cater to them. In case of edge cases, you're not supposed to cater to them. So you can have these agent interactions only working with these predefined rules. The modern implementations of these multi-agent systems usually incorporates role-based collaboration strategies. So in this scenario, what we do is we give each of these different agents a certain persona that, hey, you're a product manager, you have these, let's say, XYZ instructions, you have, let's say, access to certain tools like, let's say, Jira, or let's say even ClickUp, and so on. The other agent could have a persona of, let's say, a solution architect, that, hey, you're the solution architect, you have access to VS Code, you are also supposed to write clean code in this XYZ certain manner. We also have quality assurance agents, a developer, and so on. So what we can do is we can give each of these different agents their own personas, their own tools, their own strategies, and they can work together with each other to kind of accomplish the overall goal. We can also have model-based agents, and these usually work with like probabilistic models like machine learning models, game environments, and so on. And this is a very niche use case. You probably won't look at that. For most of you guys, the role-based method is the main one to go for. Another thing which is very important is whether the communication is happening through an agent call or a handoff. So in an agent call, what happens is we, let's say, have agent 1. What it does is it calls agent 2, it gets the response from that certain agent, and then it uses that to answer the user. But another strategy is to have handoffs. So one agent would work with the user query. Once it's done, it hands off it to a different agent. It again works with the user and it hands off to a maybe third or fourth agent. An example of this is, let's say user wants to order a certain black boot. Now the triage agent would ask clarifying questions. It will work with the user, try to understand what they're trying to buy. And once a sale intent has been recognized, what it does is it hands off all of this to the sale agent. So the sale agent now works collaboratively with the user, trying to understand what their needs are, what they're trying to order. And then once it's done, it has all of these certain information. It executes the order function to place that order. Now in this scenario, let's say the user wanted a refund instead. They don't want to go through with this order. What the sale agent would do is it would hand off this user to the refund agent. So in this scenario, the sale agent says, hey, my responsibility is done. I talk to the user, I'm done with my part. The refund agent, it's now your turn to now work with the user to accomplish whatever it is that the user wants to do. So now whatever happens next is the refund agent's responsibility, because the sale agent has handed off everything to the refund agent. Now it has no more context of what's going on with the user. It does not know what the user is saying next or like what conversation is happening. All of this is the responsibility of the refund agent. Now let's say the refund agent talks to the user, and once all of this is done, it confirms the refund, it executes that function, and this system has ended. In the agent call scenario, what would happen is the user would talk to the triage agent. So let's say this is the triage agent. The triage agent would then call the sale agent. So it would call the sale agent. Once all of that is done, it will come back to this agent. Then let's say the user wants a refund. So it sends it back to the refund agent. And the refund agent, once its part is done, it sends it back to the triage agent. Depending on your certain scenario, you would either use an agent call or an agent handoff. If this certain agent, the one that's initially talking to the user, if it needs to still have context of the entire conversation of whatever the user is interacting with our system, In that scenario, you would preferably use agent calls. But if it only has a certain task or like a local subtask it needs to accomplish, and after that it does not need to know anymore what the user is saying, what they're interacting, it has no further responsibility, in that scenario you would usually use handoffs. Now there's also a few considerations for the state and memory management. So you need to consider whether the sub agent gets all of the messages or like a certain amount of messages, or maybe it just gets the task or like subtask that it needs to accomplish. All of these result in very different sorts of results. Sometimes an agent is supposed to only be called as a tool. So let's say this parent agent, it only calls this sub agent as a tool. It says, hey, you just need to accomplish this, give that result to me, and I'll figure out the rest. In certain scenarios, all of the different contexts, so all of the different conversation that's had with the user, how, which other agent is called, which tools it's executed, all of that context needs to be sent to this sub-agent in order for it to function properly. Now, when you're making your system, you need to try these things out, figure out whether you need to send the entire context or just maybe call an agent as a tool, because let's say if it's a simple agent, the sub-agent just needs what it needs to do, how it's supposed to accomplish that task, then in that scenario, you don't need to send the entire conversation history. There's trade-offs for this. There's accuracy versus hallucination and cost trade-offs. So if you send the entire context, it's more accurate in certain scenarios, but you also incur a lot of more cost because you're sending more tokens to that LLM. And in other scenarios, let's say if you don't send all of that conversation history, you just send the individual tasks that agent is supposed to accomplish. In that scenario, you may or may not lose out on some accuracy, but you're saving a lot on cost. Now, in this scenario, there's a chance that because the local task which that agent is supposed to accomplish, that local task may be different from the global task. It may hallucinate, it may not, and again, this depends on how your system is configured. In some scenarios, you do need better management. So, if you're working with all of the shared states and everything, each agent must know what's mine, what isn't, what tool I called versus what tool was called by another agent, and maybe a few differentiating factors as well, because then if not, it can get confused. Now, each of these systems aren't without their faults. So there are a few possible problem scenarios that can occur in these multi-agent systems. Like I mentioned, there is a recursion issue. For example, if an editor is tasked to make the content non-technical versus a proofreader which is tasked to make sure the content is technical. Now, in this scenario, they may be working collaboratively or competitively, but if one is supposed to make it technical, the other is supposed to tell it to make it non-technical, these both keep clashing with each other. And let's say if the editor edits it, it will make it technical, and the other one would make it non-technical, and so on. This keeps looping on and on and on. And you usually need to tell the system that, hey, let's say if this happens for more than 5 or 7 times, let's say we choose the example of 7. So, hey, if this happens more than 7 times, you just need to stop, take whatever you have, give it to the human, ask them what they want. So in this scenario, you kind of have to be careful, and each of these different individual prompts, they kind of also have to be catered to work well with each other. This is the convergence problem. So the difference between local and global planning. Let's say if you have a certain scenario where there's like quite a few different agents and they're working collaboratively with each other to accomplish this task. Now in this scenario, let's say the local task by this certain agent was accomplished well, but it does not fit well into the global task that was supposed to be accomplished by this entire system. So like the global goal or task. In this scenario, this is a convergence problem. So while at a local level, each of these different agents are working well, in the overall system, it's not really working well. Maybe in this scenario, you would have like a shared state between them, so they each have an idea of what the other agents are doing and maybe work on top of that. But this also leads to communication overhead. So instead, if you just had one single agent, it just needs to talk to one user. So you have this and this. So let's say you have the agent and the user. There's very less communication overhead going on here. But in this scenario, let's say if this was the user, this was the agent, and it's calling a few different other agents. Let's say this is the certain scenario. Now in this scenario, what happens? The user talks to this parent agent, it talks to this agent, then then this agent, then this agent, and then it replies to the user. So in this scenario, there's a lot of communication overhead going on, and this also incurs cost because each of these pieces of communication, it has a certain amount of tokens that are being processed by these individual LLMs, and again, all of these have a cost and time associated with them. You also have to be kind of careful about the memory and context management. A lot of systems don't do this well, and because of that, even though a task is accomplished at the local level, the global task is usually not achieved. There's also sometimes scalability and trust issues. So let's say if your system is not working well, how do you know if it's like agent 1's fault or agent 2's fault or agent 3's fault or agent 4's fault and so on? And maybe it's not even their individual faults. Maybe the communication between these agents is broken, or maybe certain things are being shared correctly. So you kind of need to figure all of that out to kind of mitigate these trust and scalability issues. And these are just a few problems associated with these systems. And that's it for this video. I hope you guys learned something new. I had a lot of fun teaching you guys, and bye bye.